just as you see it up on the board on your cell phones. Those questions that you want to ask will go over here to Lori in the corner, and she's going to text them, basically, send them over to me so that we can try and get as many questions as we can, okay? That way we're not trying to have people shout out and talk over the speakers as they're trying to talk. So really want to be this as seamless as possible. So if you can, just go ahead and log into slido.com, type in ProMoly, and you can just go ahead and enter in your question as we come up, okay? We'll get ready. We've got a few more people coming in. We'll get started here as close to 10 as we can, all right? Thanks, everybody, for coming. We appreciate it.
You are a handsome son of a bitch. You know that? I mean, you take care of yourself. You clean up. Oh. Yeah. Well, thank you. Yeah, I want everybody to know. I want the world to know.
That one on the
My
edges,
face is red.
on the right rear.
Sign language.
All right. So good morning again. We're going to go ahead and get started. It's right at about 10 o'clock. I'm going to try and not have the background here from the speaker, and then I'll definitely get out of the way here. But please make sure if you want to send us a question, log into slido.com, type in ProMoly on your cell phone, tablet, whatever you have. Those questions will go to Lori. She'll funnel them to me. Okay? All right. Well, good morning. Welcome to the Trust the Pros Welding Tips from the Experts, sponsored by Plymouth Tube ProMoly. So up here at the head table, we have Mike Long from EMI. We have Joe Fitzpatrick from Don Schumacher Racing. We have Lon Damon from Lincoln Electric. I'll kind of get out of the way here a little bit. We have Steve Kent from KPC, and we have David Stremming from Lethal Chassis. So guys, thank you for coming. So, and thank all of you for coming as well. We really appreciate this. So tell you a little bit about Plymouth Tube. Plymouth Tube came up with ProMoly back in 2007, all right? ProMoly is chromoly tubing. It is very well known in the industry. It's a branded product by us, and we have the staff here. If you see everybody in white, it went silent on me. If you see anybody in white, after the seminar, if you have any questions, please feel free to reach out to us. We are located at booth 100, all right? So whatever we don't get answered here today, we will be able to answer at our booth, okay? So, talking about our product, we have a mission statement that I'd like to read off to you. And our mission statement says this: we are committed to provide products and services that meet and or exceed our customers' expectations. And the reason I read that mission statement is the fact that today, we're not going to talk about products, okay? We are going to talk about services, because Plymouth Tube is a service organization. We're a problem solver, solutions provider, and we want to bring the experts to you. We want to solve your problems. As we at Plymouth Tube, many, many times we get asked, how do you weld the product? How do you fit it together? We're tubers. We produce the tube. The people up here at the panel, they're the experts. And so we want you to feel free to ask those questions that you ask us on a daily basis, because, again, we can produce the product. These guys build the end product, and they're going to be able to answer your questions. All right? All right. So, guys, are you ready? Yeah? These guys were so excited this morning, came in and met with us first thing. You know, after a night out on the town, we said, we got to get together real quick so we're ready to go. So, all right, guys. Mike, I'm going to start off with you. Why do you do what you do, and why are you so passionate about it?
Competitive person by nature. The motorsports industry it feeds my need. All of us are driven by something, and being a competitive person, you get a report card every day you go to the racetrack. And as I'm sure all of you are there, just as well as I am, you finish the evening and you get that report card. And that's what we strive for, and that's what drives me is every week you got to be on your toes, you got to stay on top of it, and continuously push to stay ahead. And that's why I love motorsports, and that's why I do what I do.
Joe, how about you?
I grew up racing. It was a family thing for me. Wanted to pursue it as a professional level when I grew up. Still kind of waiting to grow up. So I wanted to pursue in a professional level, so I could compete against the best there is, and kind of find out where I measure up against that.
Yeah, I grew up watching racing as well, and just kind of sort of transitioned into the sports marketing department at Lincoln Electric. So I'm very fortunate to be working with everybody in racing. So supplying the teams with what they need to build the chassis.
I grew up around racing. I grew up around the Vukovic family there in Fresno, and I've gone from quarter midgets to micros into sprint cars, drove for 20 years. It's my sport. I love it. And I'm really passionate about building the best car that I, myself and my son, that we can put out of our shop. And it's my sport, and that's all I can say about it. It's what I love to do.
Well, a lot like these guys, I grew up around racing, and bottom line is I didn't want to work. All I knew was racing. So, but to be serious, I love the competition, love the family atmosphere, and I love that you can take something and run against the very best and beat them, and it's a constantly changing sport, unlike other businesses or anything else. So I have an asphalt background, all of a sudden switched to dirt racing, something totally different, new challenges, and I really enjoy that part of it.
Great. Why did I get into tubing? Because of these guys, right? It's what we do, producing the product to enable them to have that success on race day. So guys, thank you for that. So all right, let's go ahead and start. So starting out, David, I'll start with you on this end. Talking about tubing and talking about starting to build a chassis, is there any pre-treatment that you need to do to the tube before you start your processes?
In our process, we don't do any preheating or anything. A lot of our stuff, and we're fairly new compared to other motorsports of using the Pro Moly 4130. We started actually about a year and a half ago looking into it. Our cars were mostly all DOM cars. And for our business, we only do 20, 25 cars a year, a lot like Kent. We're not into big production. We're into more specific. We want to have the best available equipment. And we did a lot of research on it. And as you know, there's a lot of forms of materials out there. What was interesting to find is other motorsports using this material. And then we did some research, and even some of my competitors were playing with it and doing some stuff. So I'm really, really happy with the performance, most of all the consistency. Our building and our partnership with Stock Car Steel, we're 4 buildings down. I can go in and see all the runs. I mean, every material he gets. And we've been very, very happy with everything we've seen. And my personal cars are all built out of the Pro Moly, and it's turned into, now my customers have seen, I've, not needless to say, I'm not happy about this, but we've crash tested some stuff and been very satisfied with everything we've seen.
Good. I'm going to jump down to Joe real quick. Joe, different drag racing. What's your metal prep, and talk to us a little bit about what you do.
Yeah, when we get ready to build our cars, we polish all of our tubing inside and out. We touch the whole length of it, just looking at it, make sure it's very clean, wipe everything down with acetone. And all of our tubing, we do a lot of testing to all of it, so it's all serial numbered, so then we keep track of all that. So there is a lot of work to be done to the tube before we even lay it into a car. Is it excessive? Yeah, probably, but for me, it's one of many steps that you take to build the best race cars you can.
So Kent, this came in from the audience, and hopefully you can answer it, but it says, provide details on how adequate to clean the inside of the tube and how far beyond the joint. Do you do any of that? Yes,
Yeah,
Steve.
we wipe the tube down with acetone, like what they do, so you don't have anything that's going to contaminate your weld joint. It's just as easy. You think just wiping the outside gets it done, but you can get contamination from inside your weld, inside the tube, just as easy, and it'll suck it up into your weld. And you may think that you have a good weld on the outside, but it's full of porosity on the inside. So it's very important to clean the tube inside and out, and just make sure it's free of any contaminants.
Good. Mike, to you down to the end. MIG or TIG? What do
We're
you
all
think?
TIG,
You're all
100%.
TIG. Yep, 100%. Joe?
Yeah, no, 100% TIG.
Steve?
100% TIG.
David?
We're probably the other way. We're more of 95% MIG and very little TIG.
Yeah. Good. Another question from the audience. Can I weld 2% helium, 98% argon shield gas, or is 100% argon recommended?
We use straight argon, 100%. I don't need any help from the helium to get the heat that I need. So I go 100% argon for the purest weld I can get.
100% argon is, the helium's a little hotter than what we need. If you're gonna do some, thick aluminum or something like that, you use a helium mix, but argon's perfect.
Lon, how about you? Anything?
That's, yeah, I mean, that's what everybody does in the business, 100% argon. It's affordable. You start adding helium, the cost goes up and it's not needed, especially for thin tubing.
Another question from the audience. Are any of you welding while using vibratory stress relief?
No. We messed around with that a few years back when Jason Myers was out on the road. We tried doing that with some cars, and it just didn't work for me. Not that it's a bad thing or anything. It didn't work out for what we do, and so we did one car and didn't see a huge difference in it. I figured by the time they get glass beaded and gone to the powder coat and ran around on the racetrack a few laps, they're pretty well stress relieved.
We, on our top fuel cars, we do a vibratory setup on our chassis. We use a metal axe from Bonal Technologies. And a lot of that we use it for is the length of what a top fuel car is. It's arguable how much difference you see in it. I like the thoughts behind it to help stress relieve the car as you're welding it. And there are times when you go to, take a 300-inch wheelbase car out of a jig where you unlock everything out of it and you don't see any movement. So is it necessary to do? I don't know. I've built a lot of cars without it, and I've built a lot of cars with it. It's just another one of those steps that we take during building our cars.
Great. Another question from the audience. You often hear chromoly is brittle than mild steel, 4130 versus 1020. Is this true? Mike?
We use all 4130 100% in the production of our cars. Some of the brittleness that you may see may be self-inflicted by the welder themselves and the heat ranges that they may use and the wall thicknesses that they're trying to join. And so to me, the heat affected zone is probably the most important part of that question.
David? Anything?
I just agree with him. It's amazing as you look at all the different forms of motorsports. There's a lot of, misconstrued information out there on the product, and a lot sometimes comes back to the user and how they're using it. Same with, as they had talked about the vibrator, we build our cars in 5 sections. We don't see the need of it. We haven't seen any difference, and a lot of that come with the cup technology. And when they started Romer arming cars and inspecting them down to the thousands, you had to really work on all your fixturing and everything else, and again the process of the materials and everything else. So again, I think it comes down to user on whether it's welding or the materials or any kind of issues and processes of how you're doing it.
We hear a lot about safety in the sport, okay? Obviously, as we produce the tube, we're talking to our employees constantly about the applications that our tubing may go into. They may be into a race car chassis. They may be going into a aircraft chassis. Talk to us about how you guys view safety. And Joe, I'm going to start with you.
Safety is what it's all about. When I first started building race cars, I just wanted to build really fast race cars. Then you come to find out, that really is, second to the driver's safety. So everything we do, for us, it's focused around the driver. All the little processes we go through, maybe the extra things we go through, and the things that we do is purely on a safety aspect. I mean, and that's one of the main reasons why we use Pro-Moly, is because it's a very consistent, reliable, repeatable material. I've done a lot of testing with it, and it's the best thing that I could pick for what I do. And that is all for, thinking of every one of our drivers that gets into our race car, because at the end of the day, they've got they've got families, they've got wives, kids, husbands, whatever they have. So they are very much the forefront of, you know, our thought process while building the race cars.
Mike, how about you?
I'd have to reiterate what Joe said. Obviously, all the buzzwords, reliability, and the consistency of the material is important. And because we're building a performance-driven product, the consistency is huge. You want to eliminate as many variables as you can, because obviously as your company grows, you have to employ more people, you have to put in more quality control procedures and practices, and those things can create variables at certain times. So to be able to control those is very important. And if you can utilize the material to know that you have some consistency and eliminate some of those variables, obviously that's also going to equate to safety on the racetrack.
And David, for you, both sides of the spectrum, right? Private and then built?
Well, as we all said, we grew up in racing, and I've lost friends, you know, so safety is the number one thing. Performance is probably second. And what's surprising to me, coming from the asphalt world to the dirt is very limited on what they're enforcing. So as new materials come out and as people are using this, what I've seen, and it states in the rules, hey, you have to use we'll just say 13 gauge for the main cage. Well, these people think, you know, oh, I got Pro Moly and I'm going to build it. I can go lighter and do all this stuff. You still, which is it's a great product. You can't go from a 95 wall down to a 58 wall and think you're going to go and have the same results, you know. And I think that's really what's surprising to me. And people will build something, and I've seen this. They're like, I'm going to build this thing really light. And they get 20 nights out of a car, and I'm like, well, there's nothing wrong with the material. It's what you were doing and the type of structure that you were trying to get out of this isn't going to last. It doesn't matter what it is. So, and that goes back to the safety side. And we've seen that in many sanctioning bodies this year, where all of a sudden they're getting cars flip and cage crushes down, and all of a sudden this guy had a 65 wall cage. It's like, buddy, it don't matter. You know, you're running on a mile racetrack. This isn't going to hold up. And now there's big regulations that they're starting to enforce. Really, it went back to they should have been enforced to begin with. And as a builder and as people that I care about, I'm not going to put them in that situation. I can't afford to have 20 cars come back just because some guy wanted to get lighter and gain another 15 pounds, you know. So I think there's a lot of misinformation on that. And I've seen builders right now, especially with all the new material for our end of the market, they think, oh, I can build lighter and do this, and it's going to still be safer. Hang on, we got to back up here and still look at these situations we're putting in this, and there are regulations in because of situations we've seen in the past. So safety's number one, first and foremost. Performance is second, and that's something that we really pride on as we go forward.
And Steve, not to leave you out, how about you?
Safety first. I'm in the same position. I drove for years. I lost some friends in the sport of sprint car racing, and you see that where guys try to get away with really lightweight race cars and stuff like that, and it just doesn't pan out. You gotta take into account, you know, the way of the race car, the speeds that you're going, and everything. And we just, you know, we've ever since I've started building cars, I've used Plymouth Tube, and then went on to the Pro Moly, and it was just something to me. It's one less thing I didn't have to worry about as a manufacturer. I knew the consistency was there for me, and it's safety first, and then performance. But it weighs on you at times when you're sitting there and, you know, a car goes out. I mean, and you see it crash, and you want to go, you know, make sure that everything's okay. And we learned a lot from repairing, you know, crashed race cars, to be honest with you, and see where cars fail and this and that. And a lot of times where they fail is because it's too light of a piece of tube.
The only thing I'm going to add, and I think it was last year at the show, is Mike's car was on display where that halo on a sprint car was, I mean, this guy should have been killed, if anything else. And we were researching, looking at data, doing all this stuff on this material. When I seen that made my decision right there. Said, I'm not no engineer or anything else, but I can tell you I looked at that, and it held up. I said, that's no question asked. It was great at what that thing went through and held up and saved that guy's life.
Great. Lon, go ahead.
Yeah, I just wanted to add, you know, on the welding side with training, you know, you got the materials, but you also have who's welding that tube, that chassis. So I can go hours talking about it, but we at Lincoln stress that training, because you're going to learn safety, the proper techniques and all that, but to properly weld tubing is different than welding plate. So whether you're going to buy it from a manufactured chassis shop or you're going to build it yourself, you should have some training and not just learn from Uncle Joe. You need some time in the lab. You know, and we just talked about this the other day that, you know, trying to hire people in fabrication, yeah, I can weld. Okay, I got the certificate, but come in and do a weld test. And it just shows whether or not you weld 10 years ago or last week. But that's why we always have refresher courses. You know, you have to, I said the other day, if I had to take my driver's license test, I'd probably fail it because over the years I've bad habits, right? And that's what welders do too. They create bad habits. So you gotta stay on top of it.
Just to
go ahead.
add to Lon's comment there, something that Lincoln Electric does is they have an advanced motorsports welding seminar. And I've fortunately been able to be a part of that twice in my career some years ago. And what that actually does is it just stimulates thought. If you're someone that's interested in really studying this and becoming good at it, it's a great place to go and actually see the experts in action and then be able to take home some basic skills that you can then expand upon. And that was something that worked very well for me as a beginning fabricator some years ago, to go spend time with those experts and actually get that advice and be able to see those things firsthand. And I know some of you that are on the panel have done that as well.
Yep.
So there are resources out there just for that.
Great, great, thanks. So guys, a lot of questions coming right now about filler material and then also the cooling process. So I'm going to start with Lon to talk maybe about some of what you hear with Lincoln Electric and your experience with the cooling process on welds, and then we'll roll it out to the panel.
Yeah, so thin tubing, you're just gonna weld it and let it cool naturally. There's no post-heating or anything like that. So the number one filler you're gonna use is ER80. We recommend ER80S-D2. Excuse me. And, you know, I think that's what everybody uses. Their number one choice.
Nope.
Yeah, I mean,
Come on, Steve.
I use 70S6. I tried S2, didn't really like how it welded on the 4130. Used S6, it's got a little bit more tensile strength to it than the S2. I can get a really nice clean weld with it. The reason I don't use 80, I started noticing from doing repairs on cars that had done 80s, with all the harmonics and everything that go on in these cars, the 80 tends to crack, especially on your tabs. A lot of like Zeus tabs and mount tabs and stuff, it'll break with the 80 because it's a little bit more brittle on the 80 and it just can't take all the vibrations and everything. So we use S6 on all our cars.
yeah, we use a couple different rods on our cars, and with us, you know, since we don't have suspension on a top fuel car or a funny car, so we have to rely on our chassis to do a lot of work. We do use a lot of ER80 in very rigid parts of the car. We use some ER70 in spots of the car where we maybe want to, you know, see a lot of movement. So I think, yeah, when you sit down and pick your proper filler material for whatever you're welding together, definitely you have to look at what the piece that you're going to be putting together is going to be doing, and do your due diligence and look into it, because there are numerous rods out there that you can use for different applications. So yeah, ER80 is a big one. ER70, like you heard, there's S2, there's S6, there's B2, there's all kinds of other things. Just do some research, because there could be several different rods that you could use. And as far as, you know, when we're done, I don't do any sort of quenching. I would borderline backhand somebody in my shop if I saw them dip anything in a bucket of water. So for me, I mean, stay away from it, because it's not necessary. You're not in that big of a hurry that you can't let it sit there and cool properly. And that's just another part of building a good race car.
You can also take, I mean, we do it in our shop. Maybe not be the safest way to do this, but we self-test ourselves every once in a while. You know, if we want to try some different rods or something, we'll make a joint, a T-joint or something, and weld it, and then put it in the press of the port power and break it, and then see where it fails and see what happens. Cut the weld in half and look, making sure on your fillet welds that you're getting complete penetration. that you don't have a void in behind your fillet all the way around the tube. Test yourself, weld something up, see what it takes to break it, and you might find, we can tell you all the different things that we do, and you'll probably find that we all do something different, and we're still after the same end result, but what we do, what I do, might not be right for you, and it might not be right for you, and what I do might work for you. So it's all about your technique and what you're used to doing, and what kind of race car you're building, and if you're welding a lot of thick materials, thick to thin, in the sprint car stuff, there's a lot of thick to thin stuff all over the place. So you really just got to focus on what you're doing and what works best for you.
Good. Question from the audience. David, I'll address it to you. It says, given the fact that Pro-Moly seamless, is there a worry about orientation of the jig, like some of the pitfalls that someone may have with a welded tube?
I mean, we don't use any welded tubes in our frames at all. Even our other cars are all DOM cars right from Plymouth. Again, it goes back to the process of everything, of how we build ours in sections. That goes with like our stuff, we have everything as fixtured as we can, cools down. I think, again, it goes with that process more than anything. But we don't use any, I don't believe in any welded tube.
Mike?
We're 100% Pro-Moly, and primarily just due to indexing. When you bend tubing, you can do out-of-plane bends with a seamless tube. It's a little more challenging if you use a seam tube because it has to be in the neutral bend area. And so that sometimes can determine the engineering of your car, or how a weld joint may be engineered. And because we're all seamless with the Pro-Moly, we don't necessarily have to do that. In a production setting, where you're also considering economics, it's quick because there's no indexing of the tube needed.
Good. Joe, particular question for you that came from the audience. It says, what kind of heat setting do you use to weld a top fuel car?
So we were kind of talking about that this morning. When I sit down to weld one of our cars together, I always set my welder high. I use my foot, I use my pedal. I pulse, I do it all manually. Juan was mentioning, the kind of a starting point might be 1 amp per thou of wall thickness. Like I said, I'll set my welder maybe 120, 130 amps. The problem I see if you set your welder that way is you might start out very cold until you get heat built into the part and start getting your proper penetration. So yeah, I set mine a little higher. Like I said, I set mine around 120, 130. Then I can ease into it, find out where I want to be. And then as I go through it, I'll just maintain that heat and that puddle size all the way around my piece until I finish it out.
How about the rest of you guys? David?
And again, our MIG, it goes with size of tubing you're using. We use Pro-Moly and bumper bars, which is a lot lighter. So we use the 255 MIG, and the old SP175 you can't even find. I like that. But again, it goes with the process. And I want to talk about, I had an experience. We talk about welding and everything else. I was cup racing, first year at Ganassi, and it was right around this time. We were getting ready to go test. And there's a guy in the shop, he took his time off for Christmas. So we're going to Nashville here in January. We go there, we test, like lap 30 of this test. I hit the wall head on, blew the safer barrier off the wall, knocked the camshaft out of the back of the motor. And I didn't know what the hell went on. We looked at data and something had broke. We got to, and I still have all the pictures, we got to the center link when they welded up. This guy thought he could TIG weld, and he sit there, just buzz some welds. Oh, it looked pretty and everything else. There's no penetration. So it's very, very crucial to understand what you're welding, MIG or TIG, and know the materials. I mean, and again, I highly recommend, going to the class, but first of all, I've had that experience. Lucky to be sitting here because of the safety, but it was very scary.
Steve?
I use pulse on everything that I do, so I set my machine high also because you need a little bit more heat with the pulse because it cools. It's cooling as you weld. I don't do it with my foot. I used to, and then got a machine and got my machine set up. It takes you a while to get the machine set. If you're gonna do it automatic where you want it to be. You know, like if you have a machine with the pulse settings on it, a good starting point would be like 50% on time and maybe 50% drawback, and then you can kind of dial it in from there. But like we were talking earlier, don't lose your puddle if you're welding pulse. Don't come all the way off and lose the puddle. You don't want to do that. But I think that also helps with the pulse. It helps control the heat affected zone in the tube because you don't have all the tube just buried, your heat buried into the tube. And I also had a deal. When I first started welding up my first sprint car, I was driving a car and steering box fell off in my lap going down the straightaway at Calistoga, big half mile, and I'm wide open and it hit me in the knees. And from then on out, I told this company that was building us the cars, you want me to drive your cars? I'm welding them all up from then on out. But you'll find your own ranges. You know, some guys don't like welding with pulse. They would rather, you know, either just run straight or do it with their foot. I've had some people that have come in and they freak out when they see how I've got my machine set, and that's way too much amperage. But I don't go off of having to run wide open on the pedal. If I run past half pedal all the time, I watch the puddle and just try to stay consistent with that.
Yeah, and I agree too. Like, I set my machine high, and the one thing that irritates me if I see somebody in my shop is I hate to see anybody just bury the pedal to and just start trying to weld it together. It's just a pet peeve of mine, so I always set mine high, and I'll draw back from there. I mean, if I've got it set at 140, maybe I'm only using 60 of it. You know, maybe I'm using 110 of it. So I'd rather have it there, but yeah, give yourself some range for sure.
Mike?
Changes the ratio. You adjust the amperage on your machine, the ratio on your pedal is going to vary, and so it's just a matter of getting used to it. As these gentlemen have all said, we have numerous welders in our shop that all have varied techniques. Some use the auto pulse from the machine, others do it manually. Everybody has their own technique to get to the same end result, and we do test that, much like Steve said. We use an independent laboratory actually to do those T-joint tests for us on a consistent basis, just to test ourselves. But just to reiterate some of the things that have been said, we do an OD and ID cleanse, acetone, non-chlorinated cleaners to prep the tube. As Joe polishes his tube on the OD and ID, we actually do the OD, but just in the spots where the welding is going to be done, we do a mill scale removal in those areas. And some of that can depend on what welding rod that you then pick. Just something as a fabricator that I've noticed, when you've got mill scale, you're welding over mill scale, it actually can act like a dam. It can hold your puddle together. When you remove that mill scale, the puddle tends to wet out and run a little bit differently. And so if you're introducing a welder to a mill scale remove tube versus a mill scale tube that they might have previously been welding on, it's going to take them a little bit of time to sort it out and to get that rhythm with that type of tubing. And then, just as Steve had said, the S6 rod, it wets out differently than a 70S2 rod does. We're all 70S2 in our shop on every joint in our cars. So just a little bit different things, but and get to the same end result. So, but
Good. Lon mentioned earlier, and I'm going to piggyback on what he was saying, talking about the training classes that Lincoln Electric holds, and I think, as the guys mentioned, everyone should attend that. How long do you work with let's just call it a new welder, before you allow them to weld on a car that someone may be riding in? So, Mike, I'm going to start with you.
yeah, so our business is unique. Fortunately, we're based in Lincoln, Nebraska, and we have a very strong SEC, it's called, Southeast Community College, and they have a very strong welding curriculum. And when we needed to staff our business, I actually became an advisor to the school on their welding curriculum. And we were able then to vet students. And those students that showed the applicable skills and the desire, we were able to court and bring into our business. And when you bring them into the business, you don't immediately, they just don't go to the stand-up jig and start welding race cars together. They do some small parts and other sub-assemblies to the race cars that are potentially less critical, but only after they've been tested. And as I said, we go through our own certification process where they have to weld in a 5F position. Around a T-joint, we submit that to an independent lab They do the brake test and they report back to us on any inclusions and things of that nature. And then if they don't pass, then of course we give them time to pass. But one of the other things we do to vet future employees is we're constantly giving tours. We're engaged in the community. We like to try and spearhead the trades. And so as kids come in, I've got 3 right now that call every week, and I say, just come in and practice. Come in on the evenings. I live in our business, and so not literally, but figuratively. And so I invite them in the evenings, and they play. And I can give them some advice and things of that nature. And then when they show that they're actually to a level that they could start in those sub-assembly areas, then we could potentially offer them a position when one comes available. And we just build the rapport that way. You get comfortable with each other, and then that's how you cultivate a great fabricator.
How about you, Joe?
Yeah, very much agree. In our shop, yeah, you could come in with a lot of skill and be a great welder, but I'm probably not going to let you start welding cars together for what could be a pretty long time. In my opinion, I mean, I think it's something that, you know, it comes in due time. Whatever tech school you go through, all that, I mean, the best thing that I learned when I was a kid was, you know, that you're getting taught the most information you can for an entry-level position. So you need to be very honest with yourself about that. So you need to expect, if you're coming in as an entry-level person, that you're going to be doing entry-level work. So that's, you're welding the Zeus tabs on the car, or maybe you're prepping my tube because I'm busy building other pieces. You know, that's just all part of it to get that experience, so when the time comes and you've gained enough knowledge and enough skill that you're then capable to do it. Yeah, I don't let anybody really just walk in and sit down and start welding a car together. I think that would be reckless on my behalf, and I think it would be overwhelming to that person. So yeah, I mean, the people I pick to weld our cars together, you know, they're proven out to me that they can do what it takes, because there's, you know, welding a car together, you can say like, oh, I'm just welding this car together. Then you see what this car is going to go do on a racetrack, and what the car is going to go through in the event of an accident or anything, or just normal wear and tear, you know, vibrations, harmonics, just going around a racetrack. You know, it's a pretty daunting task. So yeah, I ask a lot from my welders, and they're going to be skilled and probably been in our shop for many of years before they're actually to the point where they're welding cars together.
Lon, from Lincoln Electric standpoint, what would you guys say is a normal time span? And is it just a gut feel, or is, you say 6 months, you know, they've got to be doing something consistent?
Excuse me. So normally we do the training, you know, it's anywhere from 30 to 40 hours a week. Depends on the person. I can't say, you know, Joe's going to be ready to weld in, you know, 3 weeks. Depends on the person, how much time you actually weld. We see it all the time. But like what Joe was saying, it's hands-on experience. I mean, even though you're going to learn how to weld, you're going to have to build yourself up to that point where you're going to be welding on a chassis, especially when you're sending someone down 330 mile an hour. It's, you know, you got to know what you're doing. But I kind of like, it's like racing, you know. A lot of people start off in the lower ranks and learn how to drive a car. Most people don't go right into a super fast car, right? So it's the same. I put it in perspective. You know, learn, get to that level before you start welding on a chassis.
And if I could jump in one more time, you know, when you're learning to weld, you know, you're being taught a skill, or you're learning a skill, and that's great. But unless you want to perfect that skill, you know, like Lon was hitting on, you know, you can teach anybody to weld. We can teach anybody to sit down and weld something together. But if you're not willing to be the best at it, then you know, maybe you ought to go find something else to do.
2 things we've learned. 1 is speed kills. You can't rush it. And 2, what does every professional athlete have to learn before they're the best? How to breathe. And that's the single biggest point that we teach to the people that come into our shop, is you find them holding their breath.
Yes.
Because they want to get to the end of that weld and do everything just right, so it's the prettiest thing at the end, and they forget to breathe. And once you master breathing, everything comes so much simpler.
So another question from the audience is, it basically talks about the carbon content, which we know obviously is within the 4130 spec. It says, do any annealing processes post-heat to try to control the rate at which it returns to face-centered atomic structure? Anybody?
That's above my head.
Yeah.
I'll be honest.
You know,
I go to a .comer and I'll say, hey, tell me what all that is. So maybe one of you guys.
I do no post-heating at all on our stuff, no.
Zero post-heating, zero annealing, no heat treating. Like I said, no quenching. We're going to prep it, clean it. You know, we back purge all of our stuff, and when we weld it, it's going to cool on itself, and then when it's that, it's that.
To address the metallurgical question part of that, it's hard to be an expert in everything, right? But part of the reason you partner with a company, a sponsor on your race team or what have you, is because one, they're great to work with, and two, because they offer resources available to you. And so if you can't find the answer, don't have the answer for something, you can reach out to those individuals and they'll have the experts to do that. And that's something that we do with Plymouth Tube, is because they have an enormous amount of resources on staff to be able to answer those metallurgical questions that we may be stuck on, or if we're trying, like Steve said, you try a different rod, you do a different thing, and you've got some experts to lean on and their experiences to try and guide you through those processes.
Yeah, and to maybe piggyback, and then David, I'll let you jump in, is, you know, one of the things that Plymouth has the ability to do is truly partner up with relationships like this, but anybody. You know, if there's a particular amount of tubing that you need and you're wanting to try something different, if you remember what I said at the beginning, is we tend to be a solutions provider. We want to work with you to find those resources, to find those means to make you successful, because we know if we enable that to happen, then we're successful at the same time. David.
One of the things I was going to talk about that Steve had hit on in repairs, you see a lot. So as we repair cars, and it was interesting when the Plymouth people were down through Charlotte week, as we repair a car, it depends how extensive the damage is, but we'll cut in pretty deep, and one of the things we do on pretty much all our cars is we'll go and burn them after they've been repaired to try to relieve any stress. And I think that's around 1100 degrees, and they said that's about close to the annealing process. And it was funny of we've seen when we burn them and relieve all that, you don't have stress in the rest of the car. That's what's hard to see, you know, as how far is that damage into it. And there's some cars I tell customers, I'm like, look, let's just get rid of it, you know. That's the biggest thing. Over the years, a guy will go, man, I got cars 15 years old, this thing's great. Well, how many wrecks has it been to, or damage? You know, you get one that's really wadded up, it's never going to be good, and we can't really see that. So it's really helped our process of being able to burn them, run them through, just repowder coat them, and we've had great success with that.
Good. Another question from the audience, and Joe, this may be directed to you, but we'll let everybody else answer as well, is what tips do you recommend to prevent cracks in high flex areas of the chassis? For example, a dragster front clip.
You know, a lot of it for us is, you know, the maintenance. You know, how we're going to look at that car over its lifespan. The front end of a top fuel car has a short lifespan. You know, we'll cut the car in half and rebuild it every 60 runs. And it's not due to any sort of cracking or anything like that. It's from what we're asking that car to do. Like I said, we have no suspension, so we ask that front end to be our suspension. So we're sending it through massive amounts of movement, range, you know, all kinds of things. So for us, it's just a, you know, part of our maintenance. This is what we're going to do. We're going to sit down. To sit down, you know, to talk about the cracking, for one, yeah, we do use a different rod. I use something not so hard, not so brittle, something with a little less tense. I'll use an ER70 up there. Something that might have a little more give to it. So it's, you know, what filler material are you going to use to put in that location of your car? Two, fitment. You know, I mean, you got to, you know, your tube fitment is key to anything you weld together, regardless if it's your roll cage, front end, a sprint car, what, you know, a drag race, a top fuel car, whatever it is. Your tube fitment has got to be the key. You know, so that's another spot for me where I think, you know, all that would pull from. So is your proper fill material selection, fitment of your tube, and what you're asking that tube to do. And then probably with any car that any of us build is just proper maintenance and looking at that race car, looking it over, properly cleaning it, taking the time to inspect it, you know, so that if there is an issue, you catch it before it becomes a large issue.
Great. Question from the audience here is, just lost it. Okay, the question was raised about how do you back purge a tubular structure?
Yeah, since we do back purge, you know, when you do tube work, you have to put a vent hole. You know, if any of you have welded tubes together, you know, if you don't, you could have a mess there at the end. So where all of our tubes fit together, we have an 1/8 inch, you know, vent hole drilled on the inside of it, so all of it starts to route together. So then we've built some plugs and some pieces and to cap off on each end of it pretty much. So then you just, and the thing about the argon that I've learned is you've got to treat it like water. Argon's heavier than air, so it's going to sink to the bottom. So you realize that. So if you plug it all up and you're going to start welding, you don't start at the highest spot, you know, because for one, all these other joints aren't welded together, so it's all going to try to start pouring out the bottom. So you know, you got to think about that in your weld process and where you're going to start. And another thing is too is the pressure. You don't have to have, you know, you don't need to build a pressure in that area. You're just looking to fill that cavity or that, you know, wherever on the back side of it. So there's a couple of different things too. I've had times before I've gone to weld a chassis together. I'm back purging it. Tell my guy, turn the bottle on. He turns it on. He wicks it up. You go to weld. You get around the end of it because it's a molten metal. It's got enough pressure, it blows out, and it's like a fireworks show. So those are just several things you got to think about also. So start low, treat it as water. You don't have to have a lot of pressure. You're just looking to get it in the area to cover it. And then wherever you fill it, it has to have somewhere to escape.
He talked about order of operations, basically, and that's important in production. And also, as David talked about, stresses in the chassis. You know, every time you apply heat to something, you're gonna put some sort of stress into it. And so having an order of operations with whatever you're building, especially if you're gonna do multiples, to have that process in place and to be able to continuously do the same thing over and over and over again. You don't jump around all over the place, and you find what works over time, and then you write it in stone and you follow it.
Yeah, we do the same thing. Every car that I weld up, I have a pattern. And I may look like an idiot when I'm doing my car, but I do every car in that same pattern. And so I know it's going to come out the same every time because we really go after the consistency. We don't do the back purge on our cars, but I do lose my mind if there's not an 1/8 inch hole drilled in there for a vent, you know, because I kind of pride myself on, can I make this tungsten tip last all day long? And,
Yep.
You know, when I get to the end, the tube blows out. It's like I'm yelling at my son, "Did you drill a hole in this?" You know. But it's very important to do that. You know, we do some stainless stuff, and of course, you got to do the back purge on any stainless that you do. But we don't do it on our cars specifically. But you know, like you touched on the fit up and everything adding up to the point when you're going to weld it really comes into play. Fit is like the most important thing that you can do. And then, you know, like I said, it's the order of operations. You do the same thing over and over again because the slightest change that you do to that can end up, you know, big, you know, in the end product.
Steve, I'm going to stay with you because a question came back. It says, can you revisit the burn process and temperatures in your process? So it was a question.
Can I revisit it?
Yeah, it says, can we revisit with Steve the burn process and temperatures?
Oh, David.
Oh, that was David.
Oh,
And what was it?
it was,
burn process.
okay, burn process and temperature. Sorry, David, I was looking at.
It's what it is because with everything, our cars get powder coated, and we run through so many different. I was telling these guys, I can tell we travel all over the country, and the chemicals. They probably see it on the sprint car stuff. They're putting in dirt now, and you see it react to the metals and everything differently. So the powder coat, we're pretty specific on my guy that's doing powder coating. So we just burn it off because trying to blast it is just killing the metal to begin with. But anyways, we went through this burn process. Really, in Charlotte area, there's only one oven, and it's kind of weird because like right now everything's backed up that they are trying to burn or do anything. But we just found it just relieved a lot of stuff. And talking with these guys again, we were down there and I just told them what I had found because many a times, and even in the cup level, we'd wreck a car and we go and that thing be terrible. It'd still be. Just wouldn't react, and we've just found it relaxes. I mean, I had a car that was through 2 wrecks really hard. We went through, replaced some of it, fixed it, put it in there, and I swear it was just as good as my new car. I mean, it was unbelievable how much it helped just relieve everything. And our cars, we kind of pride ourselves on the tolerances. I think, again, it goes back to steps and processes and making sure everything's consistent. A lot of builders, especially when you're building multi-cars, I'm on my 6th different car. I'll sell my car in a minute because I know I can repeat it, you know. And you see other guys, they won't sell their cars, you know. They brag, hey, I got this many nights. Well, why? Can you not repeat that? You know, I think a new one's always better. But when we went and fixed cars and we found in the heating process what it does to relax everything, it's been big. And again, we're doing a lot of MIG stuff, and I seen that when it started, and I think Greg can fill you in on a lot of this afterwards. But when NASCAR started Romer arming and really teching everything, you're pushing limits down to the thousands. They had to go back and work on fixturing and materials and doing stuff, and we got into where we would build everything in sections and control that better, and then put it together. And I mean, at the end of my career, we were running cars you couldn't tell one different from the other unless they did something aero-wise. They were very, very consistent. Where before, you'd have a car and it was your favorite car. That's what you run. So as we've gone into repairs and doing stuff, we just try to get as much relief out as you can, because you got to look at that frame where you're starting with is just, it's a suspension component too. And we look at compliance and everything else, and it's just like, as I've learned on the dirt side, coming from asphalt, you see different loads and you're asking different things, and it comes back to structure and what you're wanting to get out of that.
So I got time for a couple more questions, guys, and I'll just read them off and let you guys jump in. It says, and this is really probably for the panel, it's how do you prepare your notches? Are they by machine or hand? Mike, we'll start down there by you.
We're 90-95% laser cut. We use a tube laser to cut all the joints. We do use conventional tooling on some custom applications or lower runs of things. You just have to be careful. As they said, fit up's extremely important. So if you're using conventional tooling to make a cope, it'll bevel the edge of the wall thickness. It'll get way thin out at the end. You got to sand that back until you get back to your wall thickness of the material. So, and your joint should be designed that way. We've tried numerous different things with laser cutting, with different gases, nitrogen to clean cut even, and then doing weld tests on that to see if there's any advantages. And so we've got a process now that we utilize to cut all of our material, but it's primarily all through automation and a tube laser.
Yeah, and we're the other side of that. We're 99% manual notch. We've got a horizontal mill with a rotary table and a vise on it and indexed it in. And, a lot of our stuff is, we build, we might only build 10 or 15 cars a year, numerous front halves and stuff like that. We're not necessarily into like a production thing. It's our build book, it's our notes and stuff like that. But yeah, most of our notches are all done by hand. But then like Mike said, you have to go back and, clean up, because once you notch that, you'll get a deep bevel on the side of it, and you don't want to weld that, because that spot there, you don't want to weld 10 thousandths thick of material to try to something. So once you get your notch, you go back, clean it up. The one thing when I do notch is properly deburring the inside of the tube. I hate to see a guy notch a tube, go by, hit the sander, so he knocks the burr off the outside, but if there's any sort of burr on the inside of the tubing, they let it fly. So that's going back in, properly cleaning that up, getting that out of the way. I think that's just another step to take into making the best race car you can.
We also use, we do everything, we use like a Bentler notcher, or a Mittler Brothers, that's what we use. Mittler Brothers notcher, and the mill, we'll fixture on the mill and cut in with the end mills. And like I said, you do have to go back and grind the edge back so you don't lose that. Yeah, we're not, that just works best for our shop. You just got to watch your pit up, grind that back. Like you said, you don't want to weld over that little thin piece of area on the tube, and that's pretty much us.
And in our production, because we're not into big quantities, we're into quality, and we'll use the Mittler Brothers a little bit, but mostly everything's hand fitted on our stuff.
Great. Well, ladies and gentlemen, we're going to wrap up here in a few minutes. Before we do, though, I want to personally thank these gentlemen for participating in our panel. I hope that it was very worth your while. we're going to give them a little plaque just to show our appreciation. And then as we wrap up, we have a Plymouth Motorsports hat that we'd like to have every participant get on your way out the door. So our staff will be ready and waiting for you. So thank you very much for attending our seminar, and we appreciate it. We hope we provided you that service that we really wanted to do. Booth 100, if we have any more questions, look for us, okay? Thank you for coming.